So what is the angular acceleration? The angular acceleration is said to be the rate of change of angular speed or the angular velocity per unit time. That is angular acceleration. Let's say we have the object and which is to move in a circular path. Let's say from point A and let's say to point B. Let's say this is the case. And from point A, the object is having the initial velocity, angular velocity, which is given as, that should be omega I, that is initial angular velocity. And let's say at point B, the object is having the final velocity given as omega f. And say the object moved from point A to point B and covered about the time given as, let's say, a t. Now, what is the angular acceleration? Much as there is a change in actually angular speed. So now the angular acceleration, which is given as alpha, is said to be the change in angular velocity divided by the change in time, which is the same as, now should be the final velocity minus the initial velocity divided by time. So that is angular acceleration. So it can be negative or positive based on the nature of the motion. If the object is decelerating, we'll have negative angular acceleration. If it is accelerating, we'll have the positive angular acceleration. And basically it is given in rad per second square. That's the basic measure of the angular acceleration. So bear that in mind, the way the angular acceleration can be calculated in that case. Let's say the object is traveling. Let's say it is having the initial velocity given as, let's say, 2 rad per second. Let's say that's the initial angular velocity. And let's say the time to x is given as 2, let's say, seconds. And let's say the object is accelerating at a constant rate of, let's say, 5 rad per second square. So what is the final velocity of the object, if that's the case? So you can be able to have that analogy at your own. So even you can also have the initial velocity, initial angular velocity, and based on the problem that we have. So the understanding of the angular acceleration is the same way we understand about the linear acceleration, where the object is moving in a linear path. That's a straight line path. We discussed about the acceleration being given as v minus u over time, where this is the final velocity, initial velocity, this is the time. The understanding remains the same in the sense that we'll have now, in the sense that this is the final velocity in linear motion, initial velocity in linear motion. Time remains the same, and also the acceleration is given as the meters per second square, while angular acceleration has to be given in radians per second, where the meters shows the distance. Now in angular acceleration, in linear motion, the distance is expressed as in terms of the angular displacement. So bear that in mind.